Hey everyone, I am going to make a little video along with these kind of follow along notes just because I think I've had some questions. There are people kind of getting the gist of it, but I think, a video would help too. So I'm going to maybe explain a couple of these, and if you still have questions, obviously let me know. So we're doing polynomial and rational inequalities, and definitely read the instructions that go along with it. But long story short, that's fine. You always want to make sure that it's set to 0. So for example, this one wasn't, so I needed to move the 36 over. Or C wasn't, so I needed to move the 60 over. So that's the first step. And the second step is to factor it like you would normally. And actually I'm going to solve this and then I'll kind of explain what the heck is going on. So quadratic equations clearly are not going away. So we multiply the first term times the last term. 1 times negative 40. Get negative 40, and I start thinking of all these factors that would add up to negative 3. And I start listing them, and finally I come up with negative 8 and 5. So I'm actually going to erase this. All right. So we have our factors and then we solve them. So that's kind of like what you were used to normally with quadratics. You would solve it and then you'd be done. But now we've got an inequality, and what it basically wants to know is, when is this function, right, that literally reads less than or equal to 0? And I'm going to show you visually kind of what's going on really quick. So you can use Desmos to help yourself out if you want and look at this graph, but 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be a really bad drawing of this graph, but here's where the zeros are, and it looks something like this, because there is not a negative, so it's got a minimum. Long story short, where the x-intercepts are, I'm going to highlight this x-axis, is where the y value, which is what you're looking at in terms of is it greater than 0 or less than 0, it's where the y value changes. Either like all the y values here are negative, and all the y values up here are positive, right? And so we want to know from what interval it gives me it's less than 0. So based on this picture, on this graph, it looks like this graph is less than 0 in the pink, from negative 5 to 8, which I can prove that on the number line like I do on all the other ones, but I just want you to see visually what's going on. If it were to ask me which number, not which number, let's get a different color here. That's fine. Let's just say, to play devil's advocate, it asks me where it's greater than 0 for this function. It'd be here and here in this bluish purple color. Right? Because all this area is where the function is greater than 0, from negative infinity to that negative 5. Then it dips down below 0, and then it gets above 0 again from 8 to forever and ever and ever, infinity. That is why we get some of the answers that we get when we're eventually going to finish this up. So pause this if you need to. I'm going to finish this equation because I'm about to erase this, so pause it if you need to, like I said. But that is not actually solving it. That is just a visual representation of what the heck it means when we get the answers that we get. So you don't have to do that visually. I think the number line's probably easier, but anyways. And then I'm like, all right, great. there's a lot of numbers between negative 5 and 8. Let me pick some ones that I can test. Because if I actually pick negative 5 or 8, I'll get 0, and that won't help me very much. I want to find the values that are either less than or greater than 0. So I'm going to choose 0 because it's between negative 5 and 8. It's an easy number to choose. I could have chosen negative 4, negative 3, 1, 2, 4, right? Like all of those numbers are between negative 5 and 8. Then I'm going to choose a number bigger than 8. I could choose 1,000. I'm just going to choose 9. And then negative 6. Any number less than negative 5. Negative 1 million would work. It would give you the same information that you're trying to find, although it would kind of be a pain, so I don't recommend that. So I'm going to test all these values. For example, when I plugged in 9 in for my x, 9 squared minus 3 times 9 minus 40, I got a positive number. I don't even know what it is. Whatever 81 minus 27 minus 40 is, but it's positive. So I know after 8, the graph is above the x-axis. And if I plugged in 0 to that function, I'd get negative 40, aka that's a negative number. And if I plugged in negative 60, I have no clue what I'd get. I don't have my calculator with me. That's very irresponsible. I'm sorry. But I do know that I get a positive number. So you're like, okay, great. I wanted to know when this function was less than or equal to 0. So less than means negative, so it's negative here. And then I just state that interval. It's negative from negative 5 to 8. And I'm going to use brackets, and I'm only going to use brackets because it told me to. It said or greater than. If it just said less than, that's when you do the parentheses, but less than or equal to, I think I said greater than, I'm sorry. Less than or equal to, whenever it's equal to, we can use those brackets. So that's what we're doing for all of these, and hopefully that explanation helped a little bit. Sometimes you will have to, sometimes it'll already be factored for you, so life's good. If it's already factored for you, then you can just solve for x, put those values on the number line, and see for this one where it's less than or equal to 0. Sometimes you will have a number greater than 1 in front of x squared. And if that's the case, you'll have to use the box method, and you'll see that as you're going through these notes. And sometimes this will happen. And the reason this happens, like if you notice a lot of these, it'll go like plus, minus, plus, plus, minus, plus, minus, plus, minus, right? Like it kind of goes in order. But that should be negative 1, sorry. Anytime, if you were to factor this, we get x minus 4, which is the same as x minus 4 squared. And as we just learned this week with polynomials, if you have a 0 that happens twice, it's going to bounce. So let me try to sketch this really quick. It's hopefully not going to be too bad. 1, 2, 3, 4, 1. And that will go like that. Yeah. So basically, it's only negative. Oops, that's not what I want. There we go. It's only negative past negative 1. The reason it stays positive from negative 1 to 4 is because it bounces here. So it never goes below the x-axis at negative 4. Anytime you are looking at these on homework, feel free, or even quizzes, feel free to maybe just kind of sketch a little graph of it, or look on Desmos, and it might help you out a little bit. That is a word problem. Same situation we're solving. And basically the only difference with inequalities versus rationals is instead of factoring it like we would the polynomials, I'm sorry, I'm saying all sorts of words today, the rational, you're going to set the numerator and the denominator equal to 0, and those are going to be the values that you test. So in this case, like -5 and 2, and we test those, and we see where it gives us a value that's less than 0. It should be positive, sorry. And it just needs to be set to 0. So when it is not, that's what gives us kind of messes with us a little bit. And we have to find a common denominator. So if you struggle with this, if you're like, I literally have no clue what's going on, I went ahead and opened the rational notes, which are next week. And I would look at operations of rationals. It is next week, but rationals, sorry. It's not due until next week, but it's open. And so if you kind of want to look at that video to help yourself out, if the simplification of this or anything that I didn't make sense, feel free to look at that. And always feel free to reach out to me. Sorry this was kind of like all over the place, but hopefully it helps. And I hope you have a fantastic week.